In this section, I would like to introduce the topic of interoperability, which is really important in IoT systems. We briefly talk about interoperability here and there throughout the different lessons, but let me introduce the definition of interoperability first. Interoperability is a characteristic of a product or a system whose interfaces are completely understood to work with other products and systems present or future in either implementation or access without any restriction. So the communication has to be meaningful and they should be able to exchange data and services. So as you can see from the figures, compatibility is basically someone developing adapters, and then some of the systems can work with other systems. So A work with B, C work with D through some adapters. De facto standard means that one system is the main system, the others are following the standard proposed by the A, so they can everyone can communicate with A. But in a true interoperability scenario where all the systems can equally communicate with all the others. So such communications are done by having standards which are open to all the parties involved in. Currently, what we see is the de facto mode or the compatibility mode across especially the smart home domain. For example, if you look at Apple HomeKit or Samsung smart things, they are represent A, which other smaller companies with other IoT devices are complying with their formats and be able to communicate with the main smart home system. But to get the true value of IoT, we need to move into the interoperability stage where all are equally communicating with each other. Why interoperability is important in IoT? First, large scale of cooperation. Cooperation and coordination of millions of distributed devices. In order to do that, they should be able to communicate with each other without a centralized control. For example, if I am an IoT device manufacturer or producer, if I am small, if I don't have an ecosystem, I should not have the burden of developing adapters and frameworks that could fit in, one for Samsung Smart Things, the other for Apple HomeKit, the other one for Google and Microsoft. It will be a lot of pain for me as a small developer to make my device to be compatible. But if it's interoperable with a common standard, then as long as I support that standard, it will automatically support all the existing ecosystems. The second one is global heterogeneity. All these different IoT devices are heterogeneous. So everyone is using a common standard. It helps to communicate with other devices without any gateways. Third one is the unknown IoT device configuration. At the moment, configuration is very much a burden for a non-technical user. And then configuring usually means that I'm connecting my device to an ecosystem, because we are always intermediate with some kind of a gateway where I do the configuration there. But if there is a true interoperability, then two IoT devices can talk to each other because they share the same language. They know, they can see what others' capabilities, they can see what is the language they talk, and then you can communicate with the language of the common choice. And then the fourth one, the semantic conflicts. For example, IoT devices are somewhat like humans. They may talk like temperature. So when one smart home device say temperature or high temperature, then how can the other device know whether that device is talking about the temperature of the fish tank or whether the end user's skin or whether they're talking about outside temperature, or is it talking about ambient temperature inside, or is it talking about the temperature in the microwave. So when you say the temperature, we need to have the context or the semantics attached to it, what the temperature means. So if you have a proper interoperability with the taxonomy and ontology, then everyone can define the temperature and annotate them properly, so everyone else can understand what these terms are meaning in a particular given context. As I mentioned before, when we have the interoperability, any physical object can interact with any other physical object and can share information, because now they are talking the same language and share the same information. They can see each other's capabilities and needs. At the same time, any device can communicate with other devices anytime, anywhere, because now interoperability means that they no longer need gateways or any other third parties to do the translation. They have a common standard, so they can devices can talk to each other. Interoperability also enabled machine-to-machine communication, device-to-device communication, and device-to-machine communications. And they also help seamless device integration to IoT networks. Because when a new device is joining a particular network, if the network and the new device are talking the same language, then they can validate and talk to the new device and ask for authorization and authentication, and then they can let the new device to join the IoT network. But at the moment, when we don't have the interoperability, we need the involvement of humans to come and press a button and do some procedures in order to make sure that this particular device is trustworthy. At the moment, each device has a unique onboarding or connecting process which requires a human intervention. But if they are interoperable, then these procedures can be executed by other devices. Let me now go through why the interoperability is required. First, there are so many different wireless communication protocols such as Zigbee, Bluetooth, LoRaWAN, Wi-Fi, and many more. Then there are a number of different wired communication protocols. Then there are different programming languages. Then we have different hardware platforms. Then we have different operating systems. Then we have different databases. And then we have different data representation and different syntactic and semantic interpretations. And then we have different control models for each IoT device, how they are controlled. So there are a lot of heterogeneity within IoT. So without interoperability, it is really difficult to move towards autonomy without human intervention, as well as it creates the problem that there are always required intermediary to do the translation and bring these devices together. The whole point of interoperability is to deal with the heterogeneity and make them to operate like one rather than different IoT devices. Today, if you take a single IoT system, each of them are developed by using some combination of these different options. So Zigbee may combine with TinyOS and combine with C++ and may be developed by Google platform. So likewise, each of them have different combinations. So you can think about a large number of combinations, which it is impossible for a small developer or a small company to support these different ecosystems. So that is why we need interoperability. So each device can talk to the other devices without developing specific adapters and or any translation units. There are two different types of interoperability, user interoperability and device interoperability. User interoperability means that interoperability problem between the user and a device. And then the device interoperability means the interoperability problem between two different devices. So we'll talk about example in the next slide. Before we go to the example, there are levels of interoperability as well. So as you can see in this image, there is an interoperability in systems level, where how the data is represented, and then this syntactic data language. So what are the formats like RFD, RDFCS, OWL? There are many other standards. And then structural, so what is the architecture behind a system? And then the data context, so what is the context of the data? What are the vocabularies used to define a particular system? So when you're talking about the interoperability, you need to think about all the four levels of interoperability. This use case will help you to understand the device and user interoperability. So here the use case is about two different CCTV systems. So the context is that using IoT, both A and B provide real-time security services. So two devices. A is placed in Delhi, India, and B is placed in Tokyo, Japan. A, B, and you, the user, use Hindi, Japanese, English languages respectively. So the user talk English, camera A Hindi, camera B Japanese. User U wants real-time services of CCTV from the devices A and B. So the user wants to talk to A and B and get their service. The challenge is that the user does not know the device A or B. Device A and B are different in terms of syntactics and semantic notations. Therefore, it is difficult to find the CCTV device. User can't understand the service provided by A and B. Similarly, A and B do not mutually understand each other. Here there is a user interoperability problem between the user and the device, and then the device interoperability between the two different cameras. So basically each camera is manufactured by a different company. So the features, for example, how they move, how they rotate, how long they keep the data, how to query the camera storage, all of these are different. So therefore, it is impossible for an external party, for a user or the other camera to communicate with the other camera. To solve this problem, what we need is a common standard where they explain how do you move the camera, what is the rotation angles, how long each one keep data. So you can capture this data in a standardized way. For example, you can use semantic web technologies. You have ontologies which describe the capabilities of the camera and then the services behind them. And then you can have different languages to annotate the ontology. So you can say a camera in English, and then whatever the terms that you use in Hindi and Japanese can also be embedded in the ontology. And then someone is querying, then the system automatically will tell that the term camera is equivalent to this particular term in this language, and then this particular term in other language. So the computation, the computer actually querying knows the semantics are similar. So that is how we are going to achieve the interoperability, having a common standard as well as having an ontology to capture the full information about the terminology as well as the context information. We have now reached the end of lesson 5, data management and analytics. In this lesson, we talk about different types of data. We talk about the challenges in big data, challenges in data fusion, and different types of data fusion. So we classified data fusion techniques in a few different ways. And then we also talk about the importance of interoperability. So I hope the content we discuss in this lesson help you to think broadly about your IoT application design. So you know that the decisions that you need to make when you are planning your data management in your IoT systems design.